It's a tangent to a straight line.
Blue, have you banned Mobius?
Probably.
It's a tangent to a straight line.
Yeah, that's measurable.
It's a tangent to a straight line. Hold on one second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
Bollocks.
We deal with trolls gone crazy.
Complete enough to bollocks.
I'm all about that nerd life, getting kicked from every server I know.
Blue, have you banned Mobius?
We
Probably.
know these trolls are gonna lie and I'll escape for the show.
Excellent. So the surface is a two-dimensional object. Thank you.
Nerd life, baby.
Please describe a curve. It's very simple. Go.
These trolls gone crazy.
So that's basically what I said before, that you could say that it's just a line, any line. It's a bit more complex when you try to define it rigorously, but you can think of it just as any line. Can also be a straight line.
A plane is a surface that has no curvature to it whatsoever.
Hydrostatic pressure is the answer that will
Twin Boat, that's a
Can I
nutsack.
just get that? Paid NASA Shield, did you just say the nutsack drop proves the globe?
Yes, it does.
Proves the show. These crazy people gonna recognize the knowledge that flows.
If level is horizontal, it's an infinite plane.
Yeah, it has to be.
Yeah? It has to be.
That's the only shape that
It has
exists.
to be.
That's the only
Is that
shape
like
it can be.
Take the water levels, don't curve.
Like DP, he says, level is a straight line on a horizontal plane.
Wise man.
Geometric isn't necessarily the same as the geometry of the real world. Right? We want to model the real world geometrically, and you're not doing it correctly.
To attach to a horizontal.
That kind of logic is the thinking that no one deserves.
Hold on one second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
Yeah, it's gonna look super flat.
True.
You can demonstrate the nutsack drop for us then, can you?
Oh, definitely, yeah. It works on the globe every time.
He's made several accusations which have been bollocks.
Frustrating day.
If you, I'll just say this: if you let it, things be frustrating, it'll frustrate you. If you just, just go with the flow, bro, no problem.
Yeah, you're not in my reality in my life. Things have been horseshit since the house burnt. A lot of inconveniences and other things that I have to deal with, but that's not your problem. Anyway,
Okay,
I have some
can I ask you a question?
diagrams here. No, just a minute. I have some diagrams here for Unicorn Hawkeyes. He
Well
was
done.
asking for a diagram, and so go ahead, ask your question, and I can go ahead with this explanation on some diagrams here.
Yeah, because I wasn't even gonna go into your diagrams. But can I ask you? So if I cook two steaks, they're the same steak from the same cow, are they gonna taste the same?
I didn't quite get that. You have two steaks, and you're doing what?
I'm gonna put two steaks on the grill, and I season both the
steaks,
same. Yeah.
Steaks? You mean like beef?
Yeah. Meat. Yes. Food.
Okay, I thought maybe you were talking about steaks in the ground. We're talking about platters.
Nah. Yeah, that's nonsense. Let's not talk about that right now. But that if I cook,
So you have
better yet,
two beef steaks on the grill. Now what?
yeah. I season both the same way, and I eat mine. I send you yours, and I season them just the same way. Are we still eating the same steak?
No.
Why not?
They come from maybe the same piece of meat, but it's not the same steak. It might taste the same, it might look the same, but they're not the same.
Okay, I just wanted to pick your brain just a little bit. But you can go. I want to see your diagram. I'm going back on mute.
All right. Let's see, what the heck did I do? Okay, here we go. We'll put up the first diagram here. Sorry it took a while to do this because Paint is a horseshit piece of software to deal with. But anyway, let's look at this first diagram here. This is what I call Bev's concept of his water level. The blue is the water level pipes. We have 2, 4, we have 5 risers in which the, oh shit, something happened. Looks like I accidentally, oh well, there's pieces missing, but you get the idea here. Is Bev has, say, these 5 risers in his water level, and they go over, in his test, over 400 meters from A to B. So let's look at A. We're going to establish a horizontal. We're going to shoot a horizontal from A on outwards towards B. So in Bev's concept, this horizontal is going to intercept all the water heights and all these risers. They're all going to lie along this horizontal, which is a straight line. They're all going to be they're all at the same level. They're at the same elevation above the earth, all at the same height or the same level. So the horizontal from A will hit the water level at B. This is Bev's concept, and the red lines are perpendiculars to the earth, and they're at right, and they will intercept that horizontal shot from A in perpendiculars to that horizontal. This is the way Bev believes things behave. Now, as I see this, is my audio not coming through? Sugar Cube is asking if I'm speaking.
No, you're speaking just fine. I mean, as long as you can you just like keep it like short?
I did. I'm ready for the next diagram now.
So no,
Okay.
so before you go to that, why don't you speak it as in this is what I think Bev is seeing, instead of saying that. Wait.
Oh, Jesus Christ! All right, I'm out of here. Never mind.
Oh my God!
Hold on, George. Hold on. He doesn't realize what's going on today. Calm down. Reds, we've had an ongoing thing here. We're letting him finish his sentences. He's a little tired today.
I'll find another room.
Go
to
ahead,
to.
George. Please
Can't ask a question.
continue.
You're more than welcome to ask questions after I describe this. I don't mind that. Okay, next diagram. The first diagram is how Bev believes things work. This next diagram here is how I believe things work. Now let's look at this. All right, we have the same water level, except now we're on a curved earth, a curved spherical earth. I don't care if you accept it or not. You just have to understand this is how I believe things to work on this type of an earth, not a flat earth, but a curve. All right, so we have our water level. We have the same 5 risers. The water pipe is following the Earth's surface, and we have the 2 ends at A and B. Now, at A, again, we're at A, and we're going to shoot a horizontal out from A. The horizontal is perpendicular to a vertical line, the red line, to the earth, and it's shot out. Now, what will happen on the curved earth, this horizontal line is going to be parallel to a tangent to the earth, but this is our horizontal line as seen from A extended out to B, and that horizontal line will overshoot the water level at B because of this so-called drop from tangent on the curved earth. And as you see, as you go out from A, the difference between the horizontal line shot from A and the heights of the water levels gets greater and greater as you move out to B. All the heights and the risers are all at the same elevation on the earth, at the same level, or the same heights or elevations. Now, if we look at the perpendiculars to the Earth, the red lines, they're all perpendicular to the surface of the Earth, but they no longer intersect that horizontal line shot from A at a right angle. The angles change and get more and more acute, becomes much different from a 90-degree as you move out to B. All right, I'm done. That's the difference. So in Bev's case, he thinks that the line in the three metal risers, that the water heights all line up on the same horizontal, and I say no, they differ. No, they don't. If I were to draw a horizontal on the three risers in the middle, they would not be coincident or parallel to the horizontal going between shot from A towards B. Okay. Any questions?
I have one. How
Can
would
I-
you do that?
Oh, go on.
I'm sorry.
I say, can I just point out first of all, George, that you haven't actually represented the test that we did in any way at all.
No, there aren't two. Just saying, this is how you believe at least one of your water levels would work. I know you have two water levels.
Yeah, but
and
there's
you're
only
overlapping them in the center.
there's
I'm
only
just
four.
saying.
There's only 4 risers.
Yes, it's fine, but the concept is there. Is the fact that you think that the water level or the water heights in each of the risers line up with a straight line, and I'm showing you that in my concept of the Earth, they do not.
Okay, just in your concept.
Yes.
Okay.
You've got your concept. I've got my concept.
Is that why you didn't represent the test properly? Because to show the shared straight line segment?
No, I only have so much time to draw these things, and it takes me a while with Jesus. It's illustrating the principle.
It just didn't look like you understood what the test was at all.
I know what the test is, but if you look...
Why didn't you show it like you did then?
Oh my God. Beth, it just takes a long time to draw all these things proper. The thing is the concept is there. I'm showing you what you think the water levels...
Don't show me what I think, George.
I know what you think.
You don't know what I think, George.
You're telling me that the water heights in all the risers are going to line up with the same horizontal.
Don't
line
tell
up with
me
a straight
what
line,
I think,
and
George.
Oh, jeez. Okay, never mind. Horizontal lines don't curve, sugar cookie. Jesus.
Didn't we do this? Didn't we do this yesterday? The diagram.
We did something similar, but it wasn't exactly the same diagram. You want the diagram from yesterday? I saved it.
Well, that's the one where you did them properly, both of them. You did the blue and you did the different colors.
Okay. Hold on, Montreal. We'll find it.
I don't know why you redid all this again.
That horizontal line, how would one, like, let's say I wanted to do my own test, how could I physicalize this? That's not the right word. How could I physically make some marks to represent that horizontal line?
Step at a time. Step at a time. Yeah. I'm trying to first accommodate Montreal here. Please be patient.
Well, it's all about SC, isn't it?
At this point it is, because he's the one that asked the question before you.
I'm just joking. Joke.
Oh, shoot. Maybe I didn't. Hold on. I thought I saved it. Maybe I didn't. Oh, sorry, Montreal. It doesn't look like I saved it. I thought I did.
It's okay, George. I just thought like it looked similar. You know, why redraw it when you already did it? But that's fine.
No, I wanted to show the two different concepts separately, so that you first see it one way and then the other way. You know, the trouble is when you try to put everything in one graphic, then it gets too busy and, you know, it's hard to really understand everything that's going on. You know, I try to keep my diagrams simple. I don't want them to be. Oh, here's another diagram, but this isn't the one you were asking for, Montreal, but you know, it helps. Maybe I'll post it here.
Gods, what are you doing?
Oh, sorry. I thought it.
Oh yeah, I remember this one. The double.
Yeah, right. This is what happens if you take an auto level and set it up at A and shoot towards B. It shoots over B, and then if you move the auto level at B and shoot towards A, you will sight over A. That's how I understand it to work on the curved Earth.
Yeah, the consequences of being on a curved Earth are that horizontals don't act like they do in reality.
Yeah. Well, you can check that out, whether or not that's true, whether what I'm telling you is the truth or not, Bev. All you have to do is take 2 points, say separate them a kilometer, set your auto level up, shoot a range pole at B, make a mark on it, move your auto level to B, sight the mark on your range pole at B, and shoot towards A and see if you hit A. On a flat Earth, you should hit A. On a curved Earth, you won't.
Could I not just put a plumb bob at the midpoint there and say, will those horizontals be perpendicular to the vertical?
Well, you're going to establish that with an auto level.
What? You've got a drawing there. Is that not an accurate drawing? It's just conceptual.
How are you going to do that? How are you going to tell? How are you going to tell if something is perpendicular at right angles with an level?
Can something be perpendicular to both of those horizontals?
No.
No. Well, isn't that a disproof that that doesn't happen? Because horizontal and vertical are perpendicular.
Okay. Yes, that's fine if you can do that, Bev. But how are you going to establish looking through an?
I just asked you at the minute. Can you put a vertical there that is perpendicular to both of those horizontals?
No, you cannot.
No.
That was going to be my question. Oh, sorry.
Oh, God. Sorry, I was going to say, if you had another model, could you have a vertical there that it was perpendicular to?
Not for a curved surface. You could do it for a flat surface, for your flat Earth, that would work, but not for a curved surface.
That'll do. Go on, Buster.
Well, the question is how do we determine whose reality is or whose concept is indeed reality? And I'm telling you one way to do it is what I'm showing you here on this latest diagram. Take another level, set it up at A, aim towards B, make a mark on a pole at B, move your auto level to B, sight that mark, and shoot back towards A and see if you hit A where you're started. Or if it shoots over A. If it shoots over A, you know you're on a curved Earth. If it hits A, you know you're on a flat Earth. Easy test.
What if I want to
people to do this for 2 years and nobody has yet done it?
What if I want physicality to that line?
Huh? What do you mean?
Like you've drawn the lines and they're conceptual on a drawing, that's fine. But I want to bring physicality to that line.
You want to physically establish that line?
Yeah. I want it to be on something so I can reference it.
you're going to have to make a very straight, long ruler. This has been the whole problem that we've had. This is kind of the concept that you have with Brian Mullen's forced line, building some sort of a straight line fence. I mean, if you can do it, great, do it. But I'm not sure how you can do it.
So you couldn't do it with an auto level? You couldn't just...
Yes, I just said. You go to A, you set up your auto level, and you sight towards B.
I don't want to sight. I don't want to look that far through it. I want to put like something in the ground and put like a line on it. Physicality.
Okay, yeah. Stakes all along between A and B, and have your helper get 2 cell phones. You're sitting at A with the odd level. You're sighting towards B, and you have your helper sit stakes in the ground, and you tell him to move his pointer or his mark, his pen, up or down, and when it sights horizontal on the other level, you tell him to make a mark on that post. Then move to the next post. Do the same thing. You sight, and you tell him to move that pen up or down when it's coincident and is sighted by the crosshair of the envelope to make a mark on that post. Put as many posts as you want between A and B and do that. There you have your physicality.
But what happens if you can't? If it gets too far where you can't see with the auto level?
Then you're screwed.
What about if we were to use LIGO for a straight line, right? Would that be all right?
Sure. But I don't know how you're going to get there. It's
Would
a very secure site.
Would that be a like horizontal on the being on the XY plane?
Yes.
So though both of those on the XY plane would be classed as horizontals.
What? You mean the LIGO tubes?
Yeah.
Yeah, they're both horizontals at right angles to one another. Say your point A.
Okay. So, at point A, well, can we imagine if there's some perpendiculars?
Perpendiculars to what?
To the straight line that's established by that tube.
Sure, yeah. All you have to do, if you want the perpendiculars, you take a plumb line with you and you hang it and see where the perpendicular should be.
Perpendicular to that plane, though, right? Perpendicular to that plane.
The plane of
like Buster was saying, he wanted
things
to
like that plane. You got to be specific here.
The plane that it is on, LIGO. Holy
LIGO
shit, George! He was talking about making a straight line. I just said, what would LIGO be? Would that be that straight line? That horizontal plane that Buster was talking about establishing physically?
Each LIGO tube is horizontal and straight from a given point at the center of the experiment. A building there, tubes going out at right angles. Each of those tubes horizontal and straight from that point where they intersect one another at right angles. It goes out at right angles in two different directions, and those are horizontal. Yes.
That's the only place they're horizontal, is that the apex?
That's correct.
Wow. I think Blue said though that the tangent was along one side of one arm, midway point. I think is Mobius still in here? He's our LIGO guy.
The tangent to the Earth would be at the apex.
The tangent of the LIGO tubes is at the apex.
George. There is no tangent to the tubes. The tubes are straight, and they are tangent lines from the apex. You could think of the LIGO tubes as being tangents to the Earth, emanating from their intersection.
We can think of it as, but it's not really.
That's what it is. That's what it is in reality. Those tubes are tangents to the Earth established from their intersection point.
Wow.
Those horizontals are not tangent to anywhere else on the Earth other than where they meet at their intersection.
Okay, so they're perpendiculars to those tubes.
The tubes are perpendicular to one another.
Yeah. Yeah, but inside those tubes, right?
What about inside?
Well, no, I'm thinking more like to that laser beam.
Oh, yeah, okay. You could make perpendiculars, but they will not agree or not be parallel to plumb lines if you hold.
But so, if you were to have perpendicles, or what do you call them, pendulums, hanging in there, you're saying they wouldn't be hanging.
It would not be hanging perpendicular to that laser beam, no.
Oh, that's interesting.
They would be canted inward a little bit. They'd be all pointing towards the center of the Earth, which would make them off a right angle. They would not be a laser beam shining down the center of those tubes. Your perpendiculars would not intersect that laser beam at right angles. And the only place...
Wouldn't you need that, though, in order to make the beam bounce backwards and forwards?
The only place where a plumb line would hang perpendicular to the laser beam would be at the point of intersection of the two tubes where they meet.
Wow. At the splitter. That's unfortunate, isn't it? How do they do that then? How do they get that?
Well, they get what?
Well, in LIGO, aren't they meant to have that beam bouncing backwards and forwards like 250 odd times or whatever? When it's operational and running.
No, I haven't really looked into the particulars of the LIGO operation.
Obviously.
I can't go into
Obviously.
It doesn't matter.
It doesn't. It's only isn't it meant to be one of the most exact pieces of equipment?
What do you care if the laser beam is shown
that they've got?
It's just going to be backup. So who cares? All you're doing is establishing a straight line.
It doesn't matter, does it? It doesn't matter.
Well, what is your point about bouncing a laser beam versus having it just shoot one way? I don't get what that is.
It's meant to be dead straight, right? That's the point. Like,
yes, it is
Buster
dead
was
straight.
on about physicalizing a straight.
Yeah. Well, one way you could do it is have your mirror at the end of the tube. You bounce your laser beam, and you adjust the angle of the laser beam so that the return beam is coincident with the forward beam. Then you know it's straight. Right?
Adjust the angle of the... You can't, though, because it goes through a splitter, doesn't it? Can't be messing about with that laser beam.
You're being so obtuse. I mean, what's your point here? We got a straight line within the tube. You establish a straight line down the center of the tube, and you want to know whether or not a plumb line is going to hang perpendicular to that straight line.
No. I was an extra aside that. It was Buster that was asking you about physicalizing a straight. What was it, Buster?
I just wanted to like any one of those lines he's theorized that's on paper, just putting physicality to those lines.
Yeah, you can do that. Like I said, put stakes in the ground, as you said, and just put marks where the outer level says it's supposed to be horizontal.
But you don't think there's like a limit to how far you could look down through there to have somebody make a mark?
There is, of course. Of course. It depends on the optics, the power of your scope, and how easily you can read the marks on your pole. That's what determines the working range of an auto level. Working range of the auto level has nothing to do with the construction of the optics. It has to do with how easily you can read the marks on the pole.
So that's why they have to move fairly often.
Right, exactly.
So would they?
Is your Buster, an auto level, the working range of an auto level is determined not by establishing your horizontal line, but how easily can you read the markings on your range pole? And that's determined by a number of things. One, the power of the optics of your auto level. You know, the more powerful your optics, the easier you can read those numbers in your auto level. Quite typically, let's say your best auto levels have a compensator angular accuracy of about 1 arcsecond. Another thing that's going to affect you, and this is a very big effect, is the width of the crosshairs that are etched into the optics. With my good auto levels, I have determined, and with my theodolites, those tend to be the width of your crosshairs that's going to obscure what you see in the distance is on the order of about 2 arcseconds, 2 to 2.5 arcseconds. For mine, it's 2.4 arcseconds.
Over
So
what
that's
distance?
That's going to obscure what you can read on your range pole. So between the two important things is the scope magnification, the angular, or the three, angular accuracy, and the width of your crosshairs. So
it's George.
Assuming that you
Just
have
a
enough
second, George, please. It's
Which-
not 2.4 arc seconds at like a meter, is it?
Meter? What? Arcsecond is angular measure. Meter is a...
Yeah, and I'm talking about the width of your crosshair is not 2 arc seconds at a meter, is it?
Oh, no. Yeah, it is. It's 2 arcseconds no matter what distance you go up. So how much it obscures is you take your distance that you're sighting times the angular width in arcseconds, and that tells you how much in height and the distance is being obscured by the crosshair. It's 2 arcseconds, 2.4 arcseconds in my case, at any distance.
Sorry, Buster.
Well, would you say that that instrument, like let's say just an auto level, would you say it's more accurate, like a shorter, if you shorten up your sights, you know, like instead of shooting to say 50 meters, you shot to 20 meters, it would be more, you could be more accurate.
No, not necessarily, no. What do you mean by more accurate in terms of what?
Well, the closer you would get to the story pole or whatever reference mark that I want to make to bring physicality to this line, the shorter the distance, the more accurate you could be, right?
Not necessarily, because the auto level is working with angular measurements and angular deviations. So that's a linear thing. That remains basically the same no matter at what distance. What limits your usefulness of the auto level is how far in a distance can you actually read your range pole and the numbers off your range pole. In the United States, our range poles are calibrated, but have resolutions of 100th of a foot, which is basically 1/8 of an inch. 100th of a foot is 1.2 inches, or 100th of a foot is 0.12 inches, an eighth of an inch is 0.125. So it's very close to an eighth of an inch. So your graduations on the range pole is about an eighth of an inch on each one. So it basically boils down to, as you move that out in the distance, how easy hard is it for you to read those graduations on the range pole and the numbers on the range pole. And that turns out to be, when you go through like the crosshairs and the numbers that I did through, I figured it out. It works out to about 96 to 100 meters is what the effective range is on a auto level in order to being able to resolve differences on your range pole to 100.
Well, that's fine. But I'm saying, but if I shorten that distance from 100 meters to 20, I could be more accurate.
Well, again, it depends. What do you mean by more accurate? Yes, you can resolve smaller graduations on your range pole. You can see them better, so you can get better resolution, but it's not necessarily going to be more accurate in terms of angular measure, because you're measuring smaller distances in the vertical height over shorter distances, but that ratio remains the same no matter how far out you go. For example, if you can resolve, say, an eighth of an inch at 100 meters, you probably could do a 16th of an inch at 50 meters. And,
Okay.
you know, that sort of thing. But the angular deviation remains the same. It's just that, yeah, you can read finer and finer resolution at shorter and shorter distances, but that ratio remains the same. So again, you have to be kind of specific about what you mean by accuracy. You know.
Well, I want to bring physicality to one of those lines, and I'm just trying to figure out like the tool that I could use to go instead of having to look over a mile through a scope that I don't think you could look over a mile to see range
You can
poles.
if you're graduate. Yeah, you can if say at a mile. Obviously, you're not going to be able to resolve markings spaced an eighth of an inch on the range pole. They're going to have to be much wider apart and thicker in order for you to see it. That's why I build my own targets to go sight things at 6 miles. Obviously, I can't see a range pole or the markings on a range pole that's marking graduations of a hundredth of a foot at 6 miles. But I can, if I put those markings, say, a half a foot apart, I can then see them at 6 miles. So that ratio remains the same.
Does that mean, like, generally speaking, practically a surveyor doesn't use range poles with that kind of a big distance on them?
Yeah, of course, because you can't see the markings on the range pole.
So it's not a common practice by a professional to use this equipment that way?
Well, of course not. They're limited. You have what's called the working range of your auto level, and that's typically 100 to 200 meters, and that is limited by how easily you can see the graduations on your range pole, which is graduated to 100th of a foot. That's what determines the limit of using your auto level. But you can sight horizontals indefinitely out. You can go out 6 miles, 10 miles, or whatever. You're not limited by the optics for sighting a horizontal, but you are limited by how you can read the graduations and the writing on your range pole. That's what limits your working range. You got to remember, plane surveyors are interested in establishing level lines or points of
elevation.
The same elevation. Okay, and you do that using differential leveling. Differential leveling takes out refraction effects and it takes out Earth curvature effects. The fact that you have a curved Earth or refraction is eliminated when you do differential leveling. Okay, that's the whole purpose of using differential leveling. So you don't have to do calculations about Earth curvature or anything like that. You don't have that. Doesn't figure in. All you do.
So sweet. So I could use differential leveling and get my physicality to that horizontal line over a distance.
Yeah, sounds good.
No, you can't.
Yeah, so you don't take anything into account. Look.
No, because every time you're on a level, you are establishing a new vertical and a new horizontal.
No, you're not.
It's not the same horizontal.
Not when you do it, George. Have you ever done differential leveling?
Yes, I have.
How
Many
far?
times.
How far did you go?
You can go as far as you want.
Well, what? Well, that's using parallel horizontals, right? Or is he gone, or is that me?
Say, every time you move that level to a new setup, say 100 meters away or 50 meters away, you have established a new vertical and a new horizontal, and those are not parallel to the previous one.
So what's happening?
You're following a level line. A level line is at the same height. above any gravitational equal potential. That's what differential leveling does. Leveling in this case means establishing points at the same elevation. And you can do that by differential leveling, so you don't have to figure in refraction or the curvature of the Earth. It just follows naturally the contour of the surface that you're on. Means same elevation.
So wait, so if that's the case and the horizontals are never the same, then why would they have ever needed geodetic surveying?
Oh, wait, sorry, run that by me again.
Why do they say horizontal distances, George?
Horizontal distances.
Yeah. That's how you do differential leveling. Vertical changes and horizontal distances.
Yeah, what about it?
Do you not see the problem?
I don't understand what you're asking. You're just throwing out words. Horizontal,
Just horizontal
vertical.
and vertical. Yeah.
What about it?
Well, they're the two measurements that you're taking when you're doing differential leveling.
No, it isn't.
Yeah, it is.
No, it isn't.
Yes,
you're marking down numbers. No, it isn't. What you're doing is marking down elevations in differential leveling.
By measuring horizontal distances and vertical measurements.
Okay, if you want to put it that way, fine. But the horizontal distance.
So
is
you
only
are agreeing.
specific.
Was that an
No,
agreement?
no.
Because it sounded a little bit
No.
wishy-washy. After just saying definitely not, it sounded like you backtracked.
No, I'm not backtracking. You're not being specific. The horizontal distance that you're talking about is only specific to a given on-level setup. You do a back sight and a foresight, your on-level is in the middle. That horizontal is respect to the on-level at that point. You move the on-level ahead, there's a new horizontal, and it's not parallel to the previous horizontal.
Well, so that's your claim, but if that's the case, it begs the question: why would they ever have needed geodetic surveying?
What about geodetic surveying?
Sorry?
I didn't get the question. What did you say about geodetic surveying?
I'm saying if that's your claim that the horizontals always change, why would they have ever needed geodetic surveying if the planar surveying's already doing it for them?
Planar surveys don't go out very far. Geodetic survey is for long distances.
Wait a minute, though. You said that they could differential level as far as they want, right? I mean, you could go in the U.S. You could go thousands of miles if you so chose.
Yeah, that's what geodetic surveyors do. They do the same thing as plane surveyors, except that they do it over much longer distances. They do their differential leveling over miles, tens of miles.
Well, why would they need it? Why would they ever need it if the guys that are going out on the field that did the first order measurements, if they always created, as you claim, new horizontals, why would they have ever needed geodetic after that?
Well, what the purpose of geodetic surveying is to set up monuments and reference markers throughout the world. In the United States, you can go everywhere. You can go around and find these little circular discs that have been established by geodetic surveyors that give you a monument of a specific location measured very accurately. That location and its elevation are known very accurately, and it's stamped on these monuments. That's what the geodetic surveyors do. And then the plane surveyors can use these to reference their own measurements off when they're doing plane state stuff or trying to establish boundary lines or whatever. They find one of these monuments and it's reported in the journals and in the archives, and they know precisely what the latitude, longitude, and elevation is of that particular marker that they can go off.
So were the geodetic surveyors doing first order measurements to set those monuments?
Not sure. What do you mean by first order measurements? You mean in the class of measurement, like first order, second order?
Yes.
Yeah.
Yeah.
Yeah. What's the other?
Yeah. They try to go accurately as they can first.
We can't hear you again.
That seems kind of backwards.
It's a good way to get the thing out, isn't it?
Who was I talking to there, Bus? Was it Buster?
Yeah.
Yeah. What state are you in, Buster?
I'm in the Carolinas.
Okay. Well, if you go around, sure, maybe around your town, you've seen these little. They're kind of brown. They're typically bronze, and they have them cast and set in concrete around your town and in your county and that. It's the National Geodetic Survey. I mean, there's tens of thousands, hundreds of thousands of these throughout the United States. I know where there's actually 5 of them in my community that I can go off on the islands and in the towns and stuff. I found them. I come across them every now and then I make a note of where they are. And the National Geodetic Survey has done a considerable amount of work, and they've set these monuments on throughout the county. And the plane surveyors can go to one of these. They know then within, a very high level degree of accuracy what the latitude, longitude, and the elevation of that. And then they can set their base stations up there to broadcast, whether it be a GPS slave unit or whatever. They can go off those monuments to know exactly where they are and use that as a reference point.
But they had to use first order measurements to set those benchmarks, right?
Yeah, I mean, this has been done, over a century. They've been established and then reworked several times to verify. Yeah, I mean, there's been a tremendous amount of work that's gone into doing this.
Yeah, but first order measurements are done with the chains and instruments, right?
Yeah, well, I'm sure that's the way it would be GPS. Of course, that's the way they did it.
They did first order measurements with GPS?
No, you don't do the first order set. GPS doesn't give you first order, second order, third order. That has to do with more mechanical.
Yeah. No, I think I misunderstood you. I was trying to clarify. It confused me.
Sorry. Clarify what now?
It broke up. I thought you said that they did first order measurements with GPS. I misunderstood.
No. GPS is very accurate. I mean, they verified all these things using GPS. I mean, you don't have different class of measurements, first, second, third order class with GPS. Well, in a sense, you might, in terms of how accurate your GPS is, how good your GPS receiver. But most surveying GPSs run $20,000-$30,000, and these things are extremely accurate to within millimeters.
What?
Yeah.
Now, you said they verified it with GPS. Is it more like they programmed GPS with the true measurements from the ground? That must be how they did it.
Well, no, what you start out with is the GPS, the software within GPS established, probably from Greenwich, where you have 0 degrees latitude. You start off there, and there's things like in France at the Louvre, whatever, where they have like the holy latitude, longitude mark. Throughout the world, there's places like this. In the United States, we have the National Institute of Technology, NIST, where they have precise locations, and there's about like 6 of these throughout the world. There's one in Russia, one in France, United States, and other countries where they have their Institute of Standards, and they kind of have a holy mark that gives you latitude, longitude, and elevation. And then once you set up your GPS system, and put in your software, you can calibrate it to those points and then check with these 6 different locations throughout the world to make sure that your GPS system is reading out correctly. And
How
then
does
once that's done,
the GPS system work then, George?
oh gosh, I don't want to really. That the guy to ask about that that's really studied that would be like Jesse Kozlowski.
Yeah, but you said it. You calibrate it to these 6 different places. How does that process work?
I mean, once you set up your software, and that, then you can check out the readouts of your GPS to verify that it is accurately reading these points.
So you have to go to those points to do your...
Exactly. Yeah. For a GPS, that's a piece of cake. All you have to do is put a receiver there. Put your receiver there and check it. You know.
Yeah, but you'd have to go... There's only 6 places.
Well, that's what the manufacturers do. I mean, you don't necessarily go to all 6 places. Like if in the United States, you go to Boulder, Colorado. That's where NIST, the headquarters of NIST is, Boulder, Colorado. So a manufacturer wholly GPS system, they'd send it to NIST to get it calibrated. The people at NIST would take that receiver, put it at their holy spot, and see what the receiver is reading out, and then tweak it if it needs to be corrected.
What's it reading?
It's reading the 3 coordinates, the X, Y, Z coordinates.
Where's it getting them from?
Well, it's getting that from the satellites by timing signals coming from the satellites that GPS constellation of satellites that orbit the Earth.
And it gets a Z-axis.
Oh yeah. Yeah. 3 coordinates, X, Y, and Z.
And what sort of accuracy did you say? When you said millimeters, what?
Yeah, they can do it within.
You did mean like within 100 millimeters or something like that, right?
No, millimeter, like 1 or 2 millimeters.
No.
Very, very accurate.
Way, George.
Yeah.
On the
surveying GPS system will give you spots on the Earth to within millimeters.
On the Z-axis.
Not necessarily on the Z-axis. That one's a little tougher, but as far as latitude and longitude, you can get it within millimeters, and I'm not sure as far as elevation. The elevation is a little sloppier than the latitude and longitude, but I'm not exact. We'd have to ask our local surveyor.
Have you not got a GPS
system?
system? Did you never have one of those? Did you not have a GPS system?
No, I'm never going to spend that kind of money to get an accurate surveying GPS chip.
So you didn't have one of those?
$20,000.
You said you had 300,000. I thought Did you not have one?
I have test equipment. I have electronic equipment, electronic test equipment. I'm not interested in spending a lot of money on surveying equipment. I'm not a professional surveyor. I have no need for that. I don't do surveying as a profession. I design electronic equipment. So I have electronic test equipment that allows me to do my job, which is not surveying, designing electronic test equipment.
Right, so you don't know on the vertical scale on the GPS.
Not offhand. No. All I know is from when Jesse Kozlowski came to visit me with his system, what he got the verticals with his GPS system. Once he got it all dialed in and his space station set up, he was getting readings in the Z-axis, as you say, within a couple centimeters. But he was getting the latitude and longitude within a couple millimeters.
Is that the one he put on the roof of his car?
Probably is, yeah.
Right, 20 centimeters. So where would he have put the base station then? When he was doing Rakir's Bridge?
I don't know. You'd have to talk to him.
Right. He's gone missing though, hasn't he?
No, he's not missing. He's just not interested in talking all this stuff much anymore. I mean,
Yeah.
I haven't been in contact with Jesse probably in half a year. He's just more interested in doing his job.
Yeah.
It's my understanding that GPS isn't near as accurate as the auto level when it comes out to creating a horizontal plane.
Oh, that's not true. It's far superior.
He just said
that's odd because the other day I was working on a job and the guy had a really nice GPS unit and he was using his theodolite, and I asked him, I was like, why aren't you using that? And he's like, you only use GPS if you just want to be within like a foot or 6 inches accurate. He said, I use this.
Oh, that's wrong. That's wrong. Maybe he doesn't have a very good GPS system. You know, they come in.
I think you better look into that, George. I think you might be wrong, dude.
No, this guy had really nice equipment.
Let's qualify what you mean.
George?
I said, like, when it comes to elevation.
Wait, just a minute. Let's qualify this. In terms of setting an accurate straight line horizontal, a GPS is far superior to a theodolite and an auto level. In work, yes. You can do better with an auto level, say if you're trying to establish this horizontal line or whatever over 100 meters. It depends on the distances that you're using. GPS is great for long distances.
Even over a mile, it's more accurate to use.
Wait a minute. I just asked the guy, and this was important because it was right along a floodplain, and he had to sign off paperwork to get it verified with the state so this house would be within the parameters. He had a really nice theodolite, and looked to me, I don't know for sure, a really nice GPS unit. And I got curious because he was using the theodolite. And I was like, why aren't you using the GPS? And he said, because it's not as accurate as this. I said, how accurate is the theodolite? And he held up his hand, and barely like a millimeter he held up. And I said, well,
again, it depends over the distances.
Let me finish. Yeah. He had to. I said, well, how accurate is the GPS? And he held up his hand again, and he said, about a golf ball is as accurate as you can get. And he had to work off a benchmark a mile away to make sure the house was built above the highest floodplain. And he was using his theodolite.
Yeah. Well, he may not have had the best of the Trimble GPS systems. I don't know what he had. You'd have to get his model number and manufacturer. I mean, they come on all different sorts of flavors and grades of accuracy.
I mean, I'm pretty sure the guy had really nice stuff he's doing.
Well, you don't know that for sure. You're just guessing.
Well, he was having to do it to sign off for paperwork.
That's fine, but they might not require anything better than a few inches or whatever. That's fine.
Well, I just asked him the difference, and he said that theodolite's always.
For his system, that might be true, but for the system two systems I've seen a very accurate GPS system that our local surveyor has that also does some geodesy type work. And I've seen Jesse Kozlowski's. These are very impressive systems. They're very expensive, and they can give you resolutions and accuracies on latitude and longitude on the order of a few millimeters.
But it's still all based off of first order measurements. Like they could not even have GPS if they hadn't done the first order measurements first.
Well, yeah, I agree with that.
Okay, fair enough.
So they're only as accurate as the first order measurements. And like really, when you're talking about GPS and accuracy, it's how close can they get to the analog measurements, if you will. Like these are like digital style of readings, but it was someone that came in there and physically gave the measurements first. So when you talk about accuracy, it's how accurate can they get it to an auto level, really?
Well,
right?
Not really, because
how so?
Well, like I say, you have like these 6 holy point throughout the world at the National Institutes of Standards for the respective countries, like U.S., France, Russia, and others. And the GPS with the algorithms that it has is once you establish one reference point, the GPS may actually determine the other ones a little more accurate just because of the nature of the system. I don't know this for sure,
The
but
nature. You're using some strange words, George.
So no, due to the design, just like when I design instrumentation, high degree resolution voltmeters and that, they can actually be better than a lot of the standards that people are using just because of the design architecture and how the algorithms within the instruments work. Is this whole thing of metrology is extremely important and extremely difficult to verify because you have to have very accurate standards
Yeah,
to
physical
verify
measurements,
things.
George. Very, very accurate physical measurements, they call them. First order.
Yeah, that's what I'm trying to point out. Like the
that's
GPS can only be as accurate as the measurements that are programmed into it, which are
Well,
those.
that's where I'm confused. If the first order measurements are all the horizontals are always different,
Measurements are not programmed. Measurements are not programmed into the GPS. It's the algorithms that are programmed in, and the algorithms work what the measurements are. It isn't like you have a lookup table or something in your GPS that you've programmed it. You have algorithms by getting timing signals from the satellites, and you compute what the X, Y, Z coordinates are, and you check it against these reference standards throughout the world. Now, of course, you're going to have, there may be the GPS, the very accurate GPS systems aren't going to be any worse than what you have established using, the theodolites and chains and stuff. And of course, so what you do is verify that your GPS is at least as accurate as the old methods of using. So I don't get what your concern is. The GPS gives you the proper readings compared as established at these reference points. As long as the GPS gives you the same coordinates as been established by your chain and theodolite and doing differential leveling throughout the world, you're done, right?
From a mean sea level, George. Elevations.
Lost the audio. I'm sorry, I didn't hear anything you said except mean sea level elevations. The audio dropped.
Yeah, all of the different land masses have a mean sea level, and then all elevations are adjusted to that mean sea level, aren't they?
Yeah, as far as I understand it, yeah.
Like Buster was
But
saying,
it goes
for the
beyond just mean
floodplain.
sea level now. It goes just beyond mean sea level because they have now an ellipsoid model of the Earth that's been established by international agreement. And your mean sea level is no longer the standard. It's this WGS, 83, 84 or something like that.
No, all
is this
elevations
ellipsoid
in
model.
the UK are measured to the mean sea level benchmark.
Okay.
Yeah.
Right. Well, you can reference a mean sea level to the WGS 84 or whatever. I mean, these numbers are
Not in the UK, no. It doesn't mention that.
I can guarantee you that somewhere somebody has the numbers written down that what mean sea level by the UK is in relationship to the ellipsoid, the
Do you think?
WGS 84. That's where no.
Do you think the any of the elevations would have changed after they put the WGS? You know, after they've set it everything and measured everything, with first order measurements
I would think
before
so. I mean,
GPS.
the whole idea in any sort of metrology is to maintain consistency. When you come up with a new technology, you want to adhere to what's been previously established, because my God, it creates all kinds of problems if all of a sudden you start changing, say, the length of the meter or what a second is. I mean, just think of all the repercussions that would have in terms of everything that depends.
In the UK, when we did our stuff, and like, let's say they were building a canal in the 1800s, would they have been building that on a?
Your audio.
Would they have been building a canal in the 1800s on a WGS model or with a horizontal
In the
datum?
1800s, they never had a WGS 84.
Oh, so they must have just used the horizontal datum then, right?
They would use some datum. You know, like I say, there's these geodetic markers throughout the world. They would have gone off one of those and related
What,
mean
in the
sea level to
1800s?
that. Yeah.
The geodetic datums.
Surveyors have been working on this stuff since the 1700s.
Yeah. In the
Yeah,
UK.
that's what I was.
Oh, so go on. Busted.
Oh, I'm just saying that's what I was getting on about earlier. They back then they just did the first order measurements, feet on the ground, instrument chains.
Right.
But you're saying that when they did that, all their horizontals were different.
Horizontals? Yeah. Well, of course, every time you move your auto level or your theater,
Did it break up?
Yeah, he did.
I said, yes, every time you move, physically move your auto level or your theodolite, the horizontal changes.
So how did they work that out? I mean, when did they figure out that did those guys know that back then?
A horizontal is established in your auto level by a plumb that the optics are attached to. So horizontals go off a vertical plumb line.
But those guys back then doing the first order measurements, they knew their horizontals were intersecting.
Yeah. Horizontal doesn't come into play in establishing this stuff.
So that's
It
what
does?
level is.
No, not if you're doing differential leveling. All that stuff goes away. You don't need to worry your horizontals if you're doing differential leveling.
What?
Yeah.
Did you just do away with horizontals in differential leveling?
Yeah, you don't need to know what your horizontals are. All you're doing is finding equal points of elevation. You can do it without knowing anything about horizontals.
How do you do that? How do you get equal points of elevation?
Differential leveling. You take your auto level, you set it up, and you set two range poles equidistant from your auto level. You do a backside. Say on your backside pole, you want a certain elevation. Say you mark off 5 feet. Your range pole is set up so, you know, one of the marks is exactly at 5 feet. So you set that from your auto level, and then you do your foresight to the other range pole, and you do your range pole mark, and you know that that mark is exactly at the same elevation as a backside.
So what kind of distance are we talking here? Those poles from the auto level?
And the working range, typically for an auto level, is somewhere between 100 and 200 meters. It depends upon what the power of the scope is and how thick your crosshairs are. That obscures your measurement. It boils down to how can you read the marks? Can you differentiate between two adjacent marks on your range pole? That's limited by distance.
Did you say? Meters. Yeah. Did you say in between 100 and 200 meters?
I was gonna say 100 meters even sounds a little rich, George. Even 75 would probably be the max, I think.
Well, you look at some of the spec, depends on the manufacturer, and not all the same. It depends on the optics in your auto level.
I don't know a surveyor that would go over 75.
Well, I don't know.
Sorry.
God, wait a minute. We don't know what the equipment is. I mean, we might not be able to get the good stuff. I mean, there might be ones that can go up to 200 meters.
Yeah. I mean, if you take a construction auto level, like a CTS Burger 24X, that's probably only going to be good up to maybe 50, 60 meters. But you take a more expensive 32X power scope, like I think Bev has one, I have one, you can go further range because you can read the numbers off your range pole at a greater distance than you can, say, for a 24X CTS Burger construction auto level.
How far can you get yours then, George?
I've never really tried to push it. I'd have to look in the what they give as the spec. I can't tell you offhand. I've never really tried to test it or verify it.
But you did say from 100 to 200.
Yeah, that's what I've seen on various auto level manufacturers, say from Trimble, Topcon.
Which
CTS
one was the
Burger.
200?
Pardon?
Which one was the 200?
There was a Trimble I was looking at one time.
Do you know the series? I'd like to check it out.
Yeah, and what was the magnification on it?
It was 32X.
Oh, well, just get a better scope. Get like 125X. Why don't they do that?
Well, it's tough to make really good optics, and it gets extremely expensive. You know, they're trying to make auto levels so they're very affordable and cheap. You know, typical.
Yeah, but you're talking about 20,000, aren't you, for a GPS system? I mean, like, imagine an auto level that could read first order over. Well, I mean, how far? Like, I mean, get a really good scope on it.
Yeah, that's fine, but serious surveyors doing long distance leveling, they use theodolites, not auto. They use expensive theodolites. An expensive theodolite.
Well, what scope do you get on that?
Yeah. Say what? What?
What scope can you get on a theodolite then?
Well, my GTS 3B is a 30 power scope.
Well, that's not as good as 32. My auto level's better than that.
There's not much difference between 30 and 32.
No, I know. So well, that's what we're saying. What's the best? Come on.
Well, the best I've seen is my Topcon 3T GTS 3B with a 30 power scope, and it has extra optics that you can attach to it to get up to about a 45.
Sorry, you cut out then. A 40 something, did you say?
I think
about 45 power. There's accessories that you can add to my theodolite to increase the power of the scope up to about 45.
45. Nice.
Did he say 45 or 40 power?
45 power.
5.
Oh, okay. Okay. So what's the big difference between the theodolite and the auto level? Like, really, what's the big difference?
A huge difference is that with the theodolite, you can measure horizontal and vertical angles accurately. You can't do that with auto level. All an auto level does is establish a horizontal. That's its purpose in life. And with modern theodolites, you can also measure distances because they have a built-in laser. And if you shoot it out to a virtual reflector target, you can determine distances to well within a centimeter. For mine is rated to go with a 9 target, an array of 9 retroreflectors. I can go out to 11,000 feet, a little over 2 miles in determining distance with my theodolite.
So basically, it's just an auto level with a rangefinder, and you can take it off level.
And
it's a theodolite with a rangefinder.
No, but I'm saying a theodolite. Sorry, I'm saying a theodolite is basically just like an auto level, except you can take it off level and it has a rangefinder. That's the only difference.
You
Isn't
No,
can measure.
the optics
Oh,
don't
there's a
work the
huge
same
difference.
at all.
There's a
Pardon
huge
me?
difference. There's a huge difference. They're not the same at all, like Bev
Yeah.
was saying. The theodolite allows you to measure very accurately vertical and horizontal angles. You can't do that with a.
That's what I said. Yeah, that's what I said. Yeah, and it's got a rangefinder.
But it's not as accurate for the horizontal, for setting
No.
the horizontal, right?
What do you mean? What isn't?
Well, the auto level is just for the horizontal, right? So for doing
Exactly.
what
That's all-
that does, that's the best thing for horizontal measurements, right?
No.
For establishing elevation markings, right?
Theodolite can do just as well, if not better, in terms of with theodolite, unlike an to check your auto level, whether or not
Can anybody else hear what he's saying?
No, he's breaking up for me too.
Okay, I'll try again. Is my audio back?
It just
So
sounds
far.
like you keep moving away from your mic, George.
But I'm not moving away. My head is in the same place for the past 2 hours.
So, what's the practical working distance between the theodolite and the measuring stick? What do you think, George? Like, what do you?
Said anywhere from about 100 to 200 meters. It depends on the floor of your optics.
No, yeah, you said that about the auto level, but what about the theodolite? Same as the auto level then?
Yeah, it's a function of how easily can you read the markings on your range.
Yeah. I think that 100 and 200 meters is really rich. I'm thinking between 50 and 75, but either way, your answer is the same as the auto level. That's what I was wondering.
Yeah. I mean, as far as working ranges in using range poles where you're reading the markings on the range pole, it's going to be the same for a level and a theodolite, using basically the same fluoroscope and the accuracy of the compensator.
So why is a theodolite better for long distance then, do you think?
We didn't say it was better for long distance.
Oh, okay. I thought that was the geodetics instrument of choice.
Well, it is, because you can.
Well, then my
elevation.
question stands. Why is it better?
No, but you're not, because you can measure vertical angles. You can tilt the scope on a theodolite that you can't do with an auto level.
Yeah, that's just for getting more extreme
If you're going
elevation.
up a hill, suppose you
Yeah.
Suppose you're going up a hill and you want to establish accurate heights. With a theodolite, you can tilt the scope up to a mark up on the hill and do your distances.
Right. Yeah, just for more extreme elevation changes. But in the end, it's basically the same tool, except it has that function to be able to help through more extreme elevation changes.
I wouldn't say it's basically the same tool. They're totally different.
And
They can do the
how do you
same
think they're
thing.
totally different?
Because you can measure, you can tilt the scope, you can measure vertical and horizontal angles.
Yeah, we
and
went
you can
through
do
that.
distance. Right.
We already agreed that the working distance of the instrument is the same as the auto level, though.
But the auto level is just a subset of the capability of what a theodolite can do for you.
Well, I tend to think they're pretty much the same, except for the theodolite can do a little bit more extreme elevation changes.
No. You can
Yeah, that's
measure
all it is.
precise angles. You can measure precise angles with the
But
theodolite.
why do you measure those precise angles? For going up hills and shit, mountains and shit, right?
You can set markers at precise right angles to one another, or at 60 degrees to one another.
Sure. You can do that with an auto level too. You can
No, you
swing it
can't.
around.
No, you can't. No, you can't.
You can't swing an auto level around?
You can, but you have a very crude set of markings on the auto level. The best you can set an angle on an auto level might be to within a half a degree in the horizontal plane with a
Yeah,
good
but you're only
theodolite
concerned
might
about the
teach you-
horizontal plane, aren't you?
With my theodolite, I can set horizontal angles to within 1 arcsec. That's 3,060 times better than a auto.
Well, an auto level just sets that horizontal plane.
That's true. But like if you have two objects in the distance and you want to know from your perspective the angle between them, the best you can do with an auto level might be a half a degree. The graduations on the base of an auto level is typically in 1 degree markings. So maybe you could go between 2 markings to get a half a degree. With my theodolite, I can get it to within 1 second.
You don't measure angles with an auto level, George.
Say what?
You don't measure angles with an auto level, do you?
Agreed. I agreed, but you can to within a degree.
Yeah, but you don't.
That's what I'm trying to tell your friend here.
No, I don't think you are.
Yes, I am.
No, the
Yes, I
auto
am.
level
I'm
is
just
a
telling him.
different tool.
Yes, that's what I've been telling him. We're in agreement
One does
there. I'm
angles.
trying to-
I think he knows that. I think he understands that.
Yeah, I know that. Yeah. Sorry, I don't mean to cause confusion. I'm just saying, basically, when it comes to measuring the horizontal plane, there's really no difference between these tools. Yeah, I
There's
understand.
a huge difference. It's
The auto level is much more accurate at establishing elevation changes than a theodolite.
There's a huge difference between a theodolite and an auto level when it comes to measuring angles in the horizontal plane. Huge difference. It's a factor of over 3,000.
Yeah, one of them measures angles and the other one doesn't. That's the major difference. One of them just deals in elevation. The other one does angles.
Yeah, I wasn't saying there wasn't a difference. I was saying for what the auto level does, the theodolite does no better in that function. That's what I'm trying to say.
Yeah,
they're equivalent.
No, they're not equivalent at all.
Yes, they are.
No, they're
yes,
not.
They are. Very much so. I have
No.
both. I have both sets of instruments, and the theodolite can very easily set a horizontal every bit as accurate as an auto level.
Okay, brilliant. So that's what you're saying then. In the tools that set elevations, or is it horizontals?
I just said for horizontal. If I want to set a horizontal to the Earth going out at 90 degrees from the zenith, the theodolite, an accurate theodolite, is every bit as good as a good
Yeah, you're breaking up there, George. Can I just get this as a scale, right? If we were to say which is the best and least accurate tool for establishing a horizontal,
laser level.
Okay, well that's one of the tools, right? Wait, George, please. Right, we've got a laser level. We've got an auto level, we've got a theodolite, and we have a water level, right?
Hi, by the way.
All right, Rob. The 4 different tools, right, George? So for establishing a horizontal, which is the least accurate?
Laser.
Laser level.
Right.
Laser.
Okay, what is the most accurate?
Theodolite.
Water level.
Theodolite and auto level. Theodolite and
A theodolite and an auto level top. Well, where's the water level then? For horizontal.
You can't establish a horizontal with an auto or with a water level.
Okay, so you put that as the worst then. George, you put that as the worst tool for establishing a horizontal, right?
Yeah, I do that. But it's probably the most accurate tool for determining elevations.
That's where we're going to go next, George. right? So let's go for establishing a level, right? Same 4 tools again.
Yep.
Which is the least accurate?
Now, that would depend upon the distance in which you want to do. For close in, I would say the best tool would be your auto level and your theodolite. But if you're going on beyond, say, several hundred meters, your water level is going to be the best. If it has a micrometer, then, you know, if it's a real precision piece of equipment.
Right. So say that again. Then what's the least accurate for short distance? Then we'll do that. Right. What's the least accurate for doing a level over short distances?
A laser level is just totally out of the question on something like this. Okay. Well, let's forget about laser levels. They're just too crude. They're just for construction. Between the theodolite and I would say your auto level and your theodolite is better unless you have some way of having a water level where you could have a micrometer adjustment. I don't know how good the very best water levels are. I've never played with a water level with adjustment. I don't.
Right. Well, did you flip the switch?
Yeah.
Did you? Because you had those tools as the best for setting a horizontal, and you say the most accurate for setting a level as well.
Close in.
So
but distance, your best for setting a horizontal is the theodolite and auto level, but the best for setting elevations would be your water level.
Right.
I was just thinking about something. Was it George the other time with a water level, and then you took a 6 foot or an 8 foot spirit level and put it on that beam? As you got to the end, in the middle it would show level, and at the ends it would show off level. Was that George that said that the other day?
Yes, that's true. Yes.
So I just got thinking about something, because there's a water level that can be accurate to, what is it, 50 thou of an inch over 200 meters. So, and they use this stuff for like machine tables and stuff like that to make sure they're perfectly level. Like, I'm wondering, George, why would they use this to make sure their table is perfectly level if they?
That's fine. That's fine for short work. You cannot move a spirit level. You cannot move a spirit level over, say, 10, 20 feet and have that bubble change much at all.
No, we're talking about 200 meters, George. Not 10 or 20 feet. 200 meters. 200 meters.
Yeah, even at 200 meters.
Hang on. Scalpel, can I help you out here? Can I read a paragraph for you?
Even at 200 meters, just a minute, even at 200 meters, the deviation due to the curve of the Earth is ever so slight that with a spirit level, you're not really going to see that change much. What I'm showing you in that diagram, I'm assuming you're moving your spirit level over a distance of, say, several miles.
What about a master machinist level? Have you ever seen one of them? Like, if you put a piece of paper under this thing, it throws it.
Yeah, you might be able to use that to do over several hundred meters. Yeah.
Can I read something? Scalpel?
Set something up, just a sec. Set something up that's 200 meters, according to flat and level, according to this precise water level instrument, and then double check it with a master level, and then you'd be what happens if this master level shows, like I said, a piece of paper literally throws it off. So if this master level shows completely level across this 200 meter piece, then you'd be convinced that that piece is completely flat and level.
Yeah, I guess so.
Interesting.
Oh, wait. Just a minute. I might have heard that one. Say that again.
Which part do you want me to say?
Well, Okay, this piece is say 200 meters long. What is this? This is a straight piece. You're saying?
Let's say it's an I-beam.
Okay, well, yeah, I-beams are going to have tolerances, but let's assume you have a perfect I-beam. Okay.
Yes.
Say it's
And you make
perfect.
that
It's
level.
perfectly straight. The surface is perfectly straight. If you sight
Right.
down the surface of this thing, there'd be no deviation from end to end. Okay.
Sure. Yeah.
Right.
And then you level it with this precise water
Okay,
level.
you go to the middle. You go to the middle and you level this I-beam. You go to the level with your machinist level. You level so that the bubble are equivalently the bubbles in the center. Okay.
Sure.
All right. Now what?
Then you check it with the precise water level from the ends. I believe it'll still show perfectly level.
Well,
Can I say something now?
That's different than what you said the other day, though,
no,
George.
it isn't. No, it isn't. No, it isn't. You're using it differently now. If you set this beam perfectly level using your machinist level in the center, you have this perfect I-beam. Now you take an auto level that is say a 200 meter auto level. You set
No, not an auto level, George. A water level.
I'm sorry, water level. You take this 200 meter water level. You set it at the ends of your beam. You adjust the water level at the left end so that the micrometer is at the same height as the surface of your beam, and then you go to the right end with the other end of your water level, and you see that it's exactly at the same height. Fine. That's going to be the same whether you're on a globe Earth or a flat Earth. They're going to register the same.
Well, I would happen to agree with you that it should be the same regardless. But it seems to me like, unless there's a huge misunderstanding, you were saying something different 2 days ago.
No. Now, if you take a spirit level, remember you leveled that beam at the center of the beam. Now you take and you move that machinist spirit level along the beam as you go towards the right end or the left end. Then it's going to register different. It's going to show that either end is higher than the middle.
Yes, this is
Okay, that is what you said the other day, and I would disagree with
geometry
that.
flat.
Okay, well, I'll have to figure out maybe a test.
Basic
The only way you can do
I called you a flat earther.
My name's
insisting that your flat earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with a sad naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Go ahead, Rob.
Did he say a five-sided square?
I just wanted to read something real quick on the water level with the micrometer. It's 1/100th of a millimeter is its accuracy.
1/100th of a millimeter. Okay, that's 10 microns. Okay.
Okay, so the communicating water level 77 is based on the law of communicating vessels. George, do you know what the law of communicating vessels is? Do you think that's just like an idea or a theory? Or do you think
I have no
it's
idea. I've never
like
heard that term. I've never heard that term before.
Okay, well, this is a Swiss-made communicating water level 77.
I don't know what that means. I'd have to study it to see what this thing is. So what's your point?
Water level. So water level for creating a horizontal plane of reference.
No, it doesn't establish a horizontal plane of reference.
Well, yes, it does. That's what it does.
Okay,
Why would you say it doesn't?
Okay, just a minute. The horizontal plane of reference that you get with an auto level is...
No, I said a water level.
Well, you shut
I said
up.
a water level.
Yes, water
So why are you talking about an auto level?
Because I'm tired. Jesus. Sometimes I get a little tongue-tied, all right? Give me a break. I've been on here.
Alright, well, it's not Jesus' fault, so you don't have to swear it. Anyways.
Why are you criticizing me?
The
Because
law.
sometimes I misspeak.
Law. Okay. I just want you to check out the law of communicating vessels.
Rob, to be fair, he
Hold on a
has been
minute.
in here hours today. So
Hold on a minute.
I just got here. I missed you guys.
Hold
I got a
on.
new headset today. I'm back.
Will you let me finish or not?
Yeah, sorry, George.
Okay, on your water level, on this precision Swiss-made water level, if you were to take the two ends and you want to establish a horizontal plane, if you drew a line between the two ends, that horizontal plane is established for the center of the water level. It's not.
So like So you would pin one side, right? You like pin it. So you got your mark at one of your vessels, right? And then you could take that other vessel wherever you want, right? Because see this communicating this tool consists of two measuring columns, a depth micrometer, and a connecting hose. The length of the hose to be defined by the user. I've posted a picture in the live chat just so you can read along with me if you wanted to. Yeah, the connecting hose, the length is defined by the user. Right?
That's
so
fine.
let's just say
Hold on a minute. Got it.
Yeah, I'm listening.
So you take your two vessels. Say one is A, one is B. You make your mark at A. Now you move B around to wherever you want. You mark at B. Okay. Now you draw a line between A and B, between those two marks.
It's a straight line.
Oh, you shut up.
That's a straight line.
Yes, you're drawing a straight line. Between
I'm just making sure I'm tracking with you, Sally. Don't worry.
I'm gonna get out of here if you're talking over me.
Keep going. Sorry.
Now, that line, that straight line that you've drawn between A and B on the two ends or the two vessels of this water level, that horizontal is only valid for the point that's midpoint between A and B. It's only valid for that point. That is not the same horizontal as you would get at A or at B, but it's only valid for the center, the midpoint between the two vessels.
What?
Yes.
Yeah, that's weird.
Doesn't make any sense.
You need. No, the water level doesn't care about the earth.
Yes, it does.
Why would you have micrometers on bits that are like both as far away from the bit that you're saying you want? What's that about, George?
It's so that you can precisely determine the heights or the elevations.
No, it's for like.
Yes, it is.
It's for measuring and leveling machine beds.
Yes.
Like
you
equipment.
Want to make sure.
Yeah.
You want to make sure. You want to make sure. Hey, stop it! You want to make sure.
Come on, George.
The machine bed.
You gotta let us have a turn too, man.
You want to make sure that every point on that bed is at the same elevation. That's what you mean that the bed is
the
level.
Same horizontal, George. Do you not understand about the straight lines?
No, it's not the same horizontal.
He can't do it, man. He can't do it.
I think you might want to look into that, George, or at least try and...
Sugar cookie.
Sugar cookie ain't even saying shit.
Say what?
I gotta go plug my phone in. I'm gonna be here still though.
You do seem to get really het up, George, about this. Like you're defending it.
Because you guys are talking over me. You are.
No, man. I was just following along with you, George. I was making sure that we were on the same page.
Rob is not adhering to the agreement that we made. That's what's pissing me off.
All right.
Well, Rob's come in late.
I was trying to get a word in edgewise. No, I missed
Rob
the beginning there.
Rob wasn't here. Yeah, Rob, we have a special.
My bad. I already have a problem with talking over people, so I should be given a little bit of grace, just a little bit. I'm sorry, Scalpel.
Listen, we made a special deal with George today that he gets to finish his stuff. Like when he says something, we let him finish. So
Like
he can't be mocked.
When we're talking, if
I'm sorry,
George starts talking, you just have to stop. Because if you carry on, then George says you're over talking him. And you just have to listen to that, because that's the agreement that we've made today.
Okay, if that's, I can understand if that's part of the agreement. I won't cut anybody off.
Well, you can do it with us, Rob. That's all right. We don't give a shit. We're used to it.
Yeah, that's what I thought. Thanks, Bev. I'm still kicking around, don't worry. I just got to go plug my phone.
Oh, I think he's gone out for 5 minutes, I think he said.
Was that a hashtag thank you, Bev? Or was that just a thank you, Bev? Just wondering.
No, mine are always legit.
I think the hashtags are legit, too.
Yeah, George has stepped out for 5 minutes now anyway, so we can... All the pressure's off. We can all just talk to each other with no problems like we used to.
I'm still wanting to know. I want to physicalize these marks, his lines, but the horizontals are intersecting.
No, I feel like he doesn't understand. Like, they designed this water level that has high precision to level out machinery tables and whatnot, to be able to go around pieces of machinery, over top of them, underneath them, all these other things. If it was like, if it's not level the way everybody normally understands level, then it's not a practical tool to use in that application. You want the machine to be level, like fucking level. Spirit level.
Wouldn't that be the most accurate tool for establishing the curve? I mean, look at how fucking exact it is. Like, why do they do that? Why would they use that tool for machine beds if what they actually wanted was the most accurate fucking curve? And why has nobody ever decided to use that for getting the curvature of the fucking Earth? They're crazy.
Yeah.
I don't know what they're doing.
They just haven't worked it out, the problems yet.
Well, I mean, I see a possibilities here, right? Because if the curvature of the Earth is out there to get fucking done, well, this is the way to do it. We could be the guys. I mean, how much money would we make? I mean, we're not flat earthers. And how much difference would it make measuring a curve in the water level?
You still got the quadratic function of the quadratic.
Shit, yeah, the you can't get around that. Nah. Still impossible then, isn't it?
Yeah.
Why wouldn't they use that to prove the curve then, these water levels? They should be like, oh, Bev, good idea. Thanks for mentioning the water level. Now we can use it to show curve.
You got to get around that quadratic function, like Buster just said.
Can I say something?
Yeah.
I thought you'd stepped out for a bit.
Yes, you can. You could use the water level to prove or disprove a curve the way I told you to do it. Okay, I'll tell you real quick. Is you take, you establish a water level, say a kilometer, and you have several risers. You have the two end risers, and say you have 2, 3 risers in the center, as many as you want between the two ends, okay? You set your water level up, then you take a theodolite or take an auto level and go to, say, the left end and sight the right end with towards the, let's say the left end is A, the right end is B. So you, after you have your water level set up, all these different risers, you take your auto level to end A and you sight towards end B, and you look to see if all the water heights in each of the risers is in line with the crosshair from the auto level. If they're all in line with the crosshair from the auto level, you have a flat Earth. If they're not all in line with the crosshair, it's a curved Earth. And I predict that what you will see when you set an auto level at A and sight towards B, you're going to see that the water heights in each of the risers as you move towards B falls further and further below your horizontal line.
What if you can't see them to reference anything?
Well, then you're screwed.
Well, then you can't prove it.
There's a way you could do it. All right. Say at each riser.
Wait a minute, George. How would you measure that?
What do you mean measure it?
Well,
I just told you.
With a measuring rod.
Or you could use a measuring rod too. You could set up a measuring rod
Wouldn't
next
that
to
be
your riser.
Wouldn't that be a difference in elevation though? Because you're using an auto level.
No.
And a drop from the horizontal is a measured change in the vertical, right?
It's drop from horizontal established at point A. Yes, you could measure it with a measuring rod.
So that would be an elevation change.
No, it's not an elevation change. Not
but
on
that's what an auto level does.
No.
Yeah, it is. You measure an elevation change.
Only if you do a differential leveling technique.
That's
with an auto level.
Yeah, but that's what you do. Foresight and backsight.
You're not listening. If you set your auto level and sight towards from A and sight towards B, you're not doing a backsight and a foresight. You're just doing a foresight. You're just looking down to the end of B, and that's different.
But a backsight and a foresight means that you move your auto level.
You're not moving your auto level. You set it at A and leave it at A and sight towards B, and then look at each of the water heights in your risers.
Usually, George, when you're doing differential leveling, the backsight is looking in that direction. George,
you're not doing differential leveling.
Stop shouting, please.
You are not doing differential leveling in this test.
Why not?
Because differential leveling will follow the curve of the Earth.
So, yeah, but let's say we have another water level going in the opposite direction. So the backsight has a water level going off in that direction. And then when we turn round our auto level, just turn it around through 180 degrees, then we've got our foresight. Because that's what it is, foresight and backsight.
Yes, what about double riding? Whenever you do a backsight and a foresight, you remove the curvature of the Earth.
George, if you've got a water level going in each direction, then you are going to measure a drop in each direction.
The instant you
Why
move
can
your
George
auto
not
level,
see this, guys?
the instant you move your auto level to do a backsight and foresight, you have removed the curvature of the Earth.
You don't move it to do a backsight and a foresight, George. Every time you move your auto level, you do a backsight and a foresight.
And you remove the curvature of the Earth.
No, you don't.
Yes, you do.
By turning an auto level 180 degrees, you remove the curvature of the Earth.
Correct.
That sounds fantastic, George.
It isn't fantastic because the Earth is symmetrical about your position of the auto level. So you have the same drop in the backsight as you have in the foresight, and when you do a differential leveling, they subtract out.
That's a double drop, George.
No, it's not a double drop. It's equal drops in both directions, and when you do your backsight, foresight, they subtract out.
I'm not so sure. Have you ever done any surveying, George?
Oh, Bill.
No, I'm being serious, George. Have you ever done any surveying?
That's why plane surveyors never need to correct for the curvature of the Earth.
George,
because when you do a different,
please.
Well, you're interrupting.
You just asked me.
You're interrupting. Stop stop interrupting. Whenever you do a backsite and a foresight in plane surveying, that's why they do not have to correct for the curvature of the Earth, because a backsite and a foresight drops out the curvature of the Earth. Done.
Right. Have you ever done any surveying differential leveling?
I just told you. Yes. Y-E.
Okay, so you realise that all you're doing is just turning the auto level
All you're doing is
scope.
the scope 180 degrees, and that drops out the curvature of the Earth.
Wow. That sounds good.
Same
So
thing
that
with the theodolite.
so that's like flicking that switch, the curvature switch, on-off switch.
You don't have a curvature switch on an auto level.
I know, but you can just turn it around. You just sort of move the scope a bit, and you can have the same effect, can't you, as the curvature on-off switch?
You don't have an on switch, and what I'm saying.
I mean, in the
the
theodolite.
Yes. If you spin.
Can he finish what he was about to say?
If you spin the scope of an 180 degrees and you sight range poles equidistant from the auto level, so that you don't have any unbalanced distances between the range poles on a foresight and backside, the Earth's curvature drops out.
George, have you ever done a two-peg test?
Mm-hmm. Many times to calibrate my auto level.
Right, so you realise that they're not the same distance, they're offset, right?
Well, you can start the easiest way to do the two-peg test, in principle, yes, Beth, but the easiest way to do
Isn't that what you just said? That negates the curvature. So in order to do your two-peg test, to check it, you do the thing that puts the curvature there.
No, you don't.
Wait, you offset them, don't you?
There's several ways to do a two-peg test. The easiest way to do a two-peg test is you set your auto level up and you set two range poles equidistant from the auto level. You do a back sight and make a mark on range pole or read the reading of it. Then you do a foresight and read or make a mark on the range pole in the 180 degrees away. Those 2 points now, you're guaranteed at the same elevation. Now you take your auto level and say you go to the left range pole and you set your auto level up, say 10 feet away, and you sight the mark on your range pole. Then you flip the scope 180, rotate it 180 degrees, and you sight the mark on the far range pole to see if the auto crosshairs are hitting the mark that you establish. If it doesn't, then you adjust the auto compensator so that the mark is halfway in between, so that the crosshairs are halfway in between the deviation between where it's sighting and what the mark on the pole is. Then you know you're dialed in.
It shows that the marks are parallel or the same, right?
Parallel horizontals, yeah.
Right, George, with the two-peg test, just to make sure it's working and it's all exactly horizontal.
It's nothing to do with horizontal.
The auto level, yeah, of course it is.
Yes. When
I
you
know.
move the let's say you have your two. Let's say you have your two pegs, A and B. Say they're
George,
200
there's no
meters
need
apart.
for you to explain. We've already explained that to everybody already. Like I'm sure we can do it much better than you can.
Say 10 feet away from one of the pegs after you establish two marks on the two pegs at the same elevation. You have taken out the Earth's curvature at 10 feet away. The Earth's curvature is ever so slight that it's not
10 feet away.
Oh, right, okay.
Oh my God, dude.
So you do whatever you did before, but there's no curvature there. So that's all. That's fancy, that, George. Yeah.
That's not a differential leveling. When you mark,
No, that's a
move your
two-peg
auto
test,
level,
George.
it is when you
out doing your daily work.
Keep talking over me. I'm out of here.
I can't hear what you're saying, George, so I don't know whether you're talking or not.
He bounced.
Is he gone? I'm not surprised.
Yeah, he's
'cause that
gone.
was pretty fucking disturbing, that, to know that George, I mean, I don't
That's
know
bad.
if anybody listening or whatever, but George has never done any surveying ever. He's never done any differential surveying leveling. He hasn't got a clue.
He's just trying to rectify their problems and is doing even worse than no longer. I mean, I'm even at a loss for words, even how to describe it. You want to establish a line, but the only thing you can do is look down it, and if you can't see it, you're screwed. I mean, is that how things work nowadays?
Yeah.
No, he's going. I could post my picture. Sorry, Buster.
That's all right.
Well, that was good.
Come on.
I'm glad he came back for that, right? I'm still recording.
Yeah.
Yeah, I'm glad he came back, and hopefully he'll come back again. But like I say, he's told us as much as we can know, right? George doesn't really know anything about anything. And what he does know is about his model.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.